Hello, I'm Joanna, a senior data scientist, and in this video I'll help you build an intuition around variables. Variables are characteristics that describe the world around us, the society we live in, behaviors, events, phenomena, anything that can be measured with numbers or described in words. Maybe you've heard about some of these types of variables. Discrete, continuous, dummy variables, nominal, ordinal, independent, or dependent. So let's dive into it and understand their whereabouts. Variables that split things in different groups are called categorical. Categorical comes from category, which means class or group. The eyes color, the gender, the car brand, your level of education, the sizes of the t-shirt, ranks or movie genders are all examples of categorical variables. When there is no intrinsic ordering of the groups, the categorical variables are also called nominal movie genres, drama, comedy, action, animation. There is no ordering from highest to lowest. Also, the genders, female or male. When the groups of variable have a predefined order, the categorical variable is called to be ordinal, from order. The size of the coffee cup the customers buy, small, medium, or large, has a clear order attached to it. But wait a moment. Ordering can be applied to both words and numbers. Then what are numerical variables for? Well, numerical variables are expressed through a quantity. They answer the question how much or how many. For example, the number of fish each contestant in a fishing competition catches. The numbers don't have any underlying meaning. They are just a quantity. Categorical ordinal variables use ordered numbers as labels or tags, not quantities per se. Like in ratings, on a scale from 1 to 5, how satisfied are you with our products? Each number from 1 to 5 has a clear meaning and a position. Numerical variables are the price, temperature, the weight, heart rate, the number of square meters of an apartment. These are all real-life numerical variables. In data science, we distinguish between discrete and continuous numerical variables. The distinction is fairly easy to grasp with some examples. Discrete means the variable can only take on positive integer values, so things we can count. The number of bus tickets sold, the heart rate, the number of students. In real life, we can't observe 5.2 people in line. Continuous, on the other hand, means the variable can take any value within a range, fractions as well. The income of a family, the price of fuel, the monthly energy consumption, or the weight. They are all continuous variables. So look how much we've covered so far. Often, we want to study variables together as a system and learn about how they connect to each other or how they impact one another. When observed in relation to each other, variables can be dependent or independent. The dependent variable is that event or characteristic that we want to learn more about. Say, the level of skiing around students. The dependent variable is explained by characteristics called independent variables. My level of skiing depends on certain factors, whether my parents ski or not, or my childhood exposure to skiing, the country I come from, or how much I like the cold. The values of the dependent variable depend on the underlying factors. Of course, there are more ways to refer to the same thing. So whenever you see terms like the outcome or the response, just know it means dependent variable. When you see terms as predictors or explanatory variables, features or inputs, they are all referring to independent variables. We know which variables are what, but did you know the same data can be expressed as different variables? Dummy variables are just another way to represent categories by using zeros and ones. Modeling involves performing matrix operations, and matrices require numbers. The way to convert categories to numbers is by assigning a 1-0 code to every class within a vector. The length of the vector will be the number of groups where each position represents one category. So now you are covered. So let's test that knowledge. Pause and take a moment to discover possible variables in the pictograms. Okay, so the Facebook reactions are categorical nominal variables. The product rating here is categorical ordinal, and it's the same with the hotel star classification. Company sizes, small, mid-market, and large, is also a categorical ordinal variable. The number of passed exams is a numerical discrete variable. The salaries of people in IT is a numerical continuous variable. The STEM industries, STEM coming from science, technology, engineering, and math, are categorical nominal variables. The amount of water a person drinks in a day is a numerical continuous variable, and the age of people is again a numerical continuous variable. Some variables might be difficult or too expensive to observe in their primary unit. Asking people how much they earn is private information that they are not usually willing to share. But building some intervals and asking people in which interval they fall with respect to their earnings, well, now that's a different story, and is something they might give away easier. The water intake in a day is a numerical discrete variable. It can take any value in milliliters, let's say. We can convert it to a discrete variable by asking a person how many glasses of water they drank in a day. Say a museum wants to know its visitors better, so that they engage grandparents, parents, and children alike. They ask every visitor their age, because that's easy, everybody knows their age. Data scientists use the age to build the age groups and find patterns that help the museum address visitors' wishes. So the problem itself requires converting a continuous variable, like age, to a categorical variable, like age groups. And that is totally fine. So when working with data, please keep your mind open and use logic. I hope now you know more about variables. Hit the subscribe button to stay up to date with our videos. See you next time!